Good morning. I wanted to give you guys a video explanation for the practice quiz. I think everyone's had a chance to take it at this point. So you've maybe taken it once or twice, and hopefully you're getting ready to take the real quiz either today or tomorrow. So here is just a rundown of how to work through the practice quiz that you've possibly already taken on quizzes. Okay, so your first thing that you look at whenever you get to the quiz is you see an unbalanced chemical equation. So you guys recall that you've got to put coefficients in the front here, and you've got to count up how many atoms of each kind of element are on each side. So the initial count I have, I looked at silver, and I saw that there's 1 silver on the left-hand side. I see there's 3 on the other hand side, so I see the 1 and the 3. And then I see there's bromine. I see there's 1 bromine over here. And I see there's 3 bromines over here, so I put a 1 and a 3. And then I went to gallium, and I saw there was 1 over here and 1 over here. And then finally, I grouped phosphate all as 1 polyatomic ion right there. So I see 1 phosphate over here, and I see 1 phosphate over here. So that's my first thing I would do when I'm trying to balance an equation. I would definitely write it down. So if you have, I told you guys when you take the quiz to make sure that you have a piece of paper. So make sure you write the chemical equation down, because you're going to need to refer to it several times throughout the rest of the quiz, and so it's a good idea just to have that that equation written down. So then I went ahead and I balanced it, so I put a 3 coefficient in front of this. That changes my silver to 3, and it changes my bromines to 3, so I went ahead and updated my count of my bromines on the reactant side. And then everything else actually stays the same, because you can see that now I have the same number of silver on both sides, I have the same number of bromine on both sides, galliums are balanced, and phosphates are balanced. So my equation is fully balanced there with 3, 1, 1, 1. Okay, next step. The next thing they're going to give you is they're going to give you a certain amount of one of the reactants. In this case, they gave you 4.13 times 10 to the 24th molecules of silver bromide. And then they're asking you to calculate the mass in grams of gallium bromide over here. So what you're going to do, I think my recommendation is that you label the equation with the 4.13 molecules of silver bromide over here, and then you're going to label question mark grams over here. So definitely label your equation. It helps you whenever you're trying to do the calculations later, and you're going to be able to do the calculations with all the labels there. So you can see that I've set up the conversion. You're trying to go from molecules of the reactant over to grams of the product. So I have the conversion set up. Make sure that you're setting up true conversions. There truly is Avogadro's number of molecules in a mole. The mole ratio is 1 to 3, so I went ahead and put that. I got the 3 from that coefficient there, and I got the 1 from that coefficient there. And then the molar mass of gallium bromide is right there, so I have that there. And then finally, I've canceled out units that match. So molecules cancels out with molecules, moles cancels out with moles. Here, the moles cancels out with moles. So the only unit that I'm left with right here is grams, which is the goal that I have. So my final answer to this conversion is 707 grams of gallium bromide. The next question asks you to calculate the same product. So you're still calculating grams of gallium bromide, and then this time you're going from moles of gallium phosphate. So I would label that. I would label 2.19 over here, and I would label question mark grams over here. With any limiting reactant problem, it's important that you're calculating it to the same mass and the same product. So you can see that we've calculated grams of bromide both times, gallium bromide. And then down here, I do the conversion. It's a pretty simple one. The moles of gallium phosphate cancels out with moles. Your mole ratio is simply 1 to 1. And then you're going to use that same molar mass that you've already calculated. And you can see how all the units cancel out, and you're left with 677 grams of gallium bromide. So the last time you calculated it, back on our last calculation, we had 707 grams of gallium bromide. And this time we have 677 grams of gallium bromide. So you're going to compare those two numbers, the 707, and you're going to compare it to the 677. This allows us to answer the next question, which it says identify the theoretical yield. So you saw that you have this comparison. You can compare this number 707 to 677. You can clearly see that 677 is a lesser number. And you can see, most importantly, that they're the same substance. You're comparing gallium bromide to gallium bromide. Okay, you're saying if I had one reactant, I could make this much gallium bromide, but if I had the other reactant, I could make this much gallium bromide. So you're looking for which reactant allows you to produce the least amount. So that's why the lower number is the theoretical yield. And you're being careful that yield is always a product. And then finally you move on to the next easy question. If the reactant that gives you the lower number of product, that's going to be your limiting reactant. Okay, so if you recall back, it was gallium phosphate, the second calculation that gave you the lower number. So that tells you that gallium phosphate must be your limiting reactant. So I'm going to go ahead and label this LR, and that means by default that this must be your excess reactant. So I would label that EX. So LR goes over here, EX goes over here. Okay, then we come to the question, how much excess is left over? So this is a tricky one. This requires us to know which one is the limiting reactant, which we've already labeled, and which one is the excess reactant, which we've already labeled. So you're going to go ahead and start with your limiting reactant, which was 2.19 moles of gallium phosphate, and then you're going to calculate how much excess reactant. Now, as far as the units that you need to calculate the excess in, you're going to look and see what units was your excess given in. And in this problem, our excess reactant was given in molecules. So that means we need to calculate our excess reactant in molecules, because if you recall, we had a formula called have minus need equals extra, and we use that to figure out how much excess reactant we have. So it's how much excess reactant do we have? That's the number that was given to you in the problem, minus how much excess reactant do we need, and that's what we're calculating right now. We're calculating how much excess reactant we need. And then finally, we are going to, when we subtract those two, that's how we find out how much excess reactant we have that's extra. So here we have the 4.13 times 10 to the 24th molecules of silver bromide that we were given. And now we're going to subtract the 3.96 times 10 to the 24th molecules of silver bromide that we just calculated. So that's the result of this calculation right here. And then when we subtract, we get the answer of 1.70 times 10 to the 23rd molecules of silver bromide. And that's how much excess reactant is extra or left over. And then finally, we come to the very last question, which is, if you know what the actual yield is, which I would give you, so in this case, we're saying we actually produced 515 grams of gallium bromide in the lab, and then I'm going to say, what is the percent yield? So then we're going to have to basically take this given, this one that I'm giving you, the 515, and then we go back to the theoretical yield, which you've already named up in an earlier problem. You already named that 677 grams was the theoretical yield. So we just simply take the 515, the actual yield, divided by the 677, which is the theoretical yield. It's all gallium bromide because yield always refers to product. And then we multiply that by 100, and we get 76%. That's the percent yield. Okay, so the way the real quiz goes, it's exactly like the practice quiz. It's obviously a different chemical equation, but it's going to walk you through the same exact process. So again, I would have a piece of paper ready, I would have a calculator ready, and I would be just prepared to write some things down because you're going to need to refer to them again. And then at the end of the quiz, you're going to only be allowed to take the real quiz once. At the end of the quiz, it'll give me the score, and then you're going to send me a screen, or you're going to send me a picture of the paper that you did the work on, and that way I can give you credit for some of your work. This allows me to give you credit. Maybe you got the answer wrong on the quiz, but you're showing me some good work, and I can give you some partial credit there. So don't forget to submit that picture of your work that you do. Do that through Google Classroom. Do it through the same link so that I can keep them all in one spot. So have a great day, guys. You can hopefully just view this video and walk through the steps of the practice quiz in case you missed any questions and sort of clear up any problems that you have. Have a great day, guys.